So finally, we are going to be naming our first chemicals. But before we do that, we need to learn how to name our ions. So an ionic compound is going to have a positive metal ion and a negative nonmetal. So if you were looking at your periodic table, which looks something like this, all of your metals will be here on the left, and your non-metals will be over here on the right. And they're going to combine in a proportion so that their net charge is 0. So for example, if you were to look at NaCl, which is our common table salt, that would have an Na, which has a positive charge, and a Cl, which is a negative charge. And to cancel out both of those charges, you need one of each, giving you your overall compound of NaCl. But the first step to learn about these ions forming ionic compounds is the idea of monatomic ions. And that's simply a single atom with either a positive or a negative charge. And that's going to be a result from the loss or gain of valence electrons. So just as a reminder, you have your cations, which can be a monatomic ion that is positive. So these are your positive monatomic ions. Whoops, sorry. And those are going to lose your valence electrons. So if you were in your group 1A, which is right here, since it has the number 1 given to you, that tells you it has 1 valence electron, giving you that positive charge. Whereas if you look at group 2A, that's going to be a positive 2 charge. And if you go all the way over to your row 3, that's going to be a positive 3 charge. So anytime that you have a metal, it's going to be losing those electrons to become positive. Overall, those are going to be your positive cations. Whenever you are looking at how to name them, you simply take the elemental name from your periodic table and add the word ion or cation, whichever one you're more comfortable with. So for example, if you're to look at sodium or Na, the elemental name of sodium is sodium, and you can say ion to say that it is a cation, or also cation, you could just write the word out if that helps you remember. Since you know that the charges based on their location on the periodic table, you don't have to rate the charge of those guys, thankfully, because you always know the charge of those ions. Anions, on the other hand, are going to be the ones gaining those electrons, so those are going to be your negative monatomic ions. Sorry about that. There we go. And so anytime you are looking at figuring out the charge of these ions, you simply have to take 8 minus the group number. So let's take a look here. So if you were to look at fluorine, for example, it's in group 7. So if you were to take 7 minus 8, that would give you -1. And everything in this long column here is going to have the same charge of -1. Whereas if you were to look at 6A, 6 minus 8 would equal -2. And that's the charge for every single one of those atoms that are in that row, or in that column, sorry. And finally, if you were to look at 5A, if you were to take 5 minus 8, it's going to give you that -3, and that's the charge of everything in that column. So you are able to figure out all of these charges by simply subtracting from 8. And this gives you the ions, the anions that you need to figure out what name it's going to be. So, don't know where that came from. But if you were to have your element from 7A, such as fluorine, which is this guy right here, to figure out the charge, you take your group number, which is 7, and you subtract it from 8 to give you that -1. So you know what the charge will be. So if you needed to write the actual ion, that would be the symbol and its charge. So once again, that's the symbol and the charge. And if you needed to write the name, you write the first syllable. So the first syllable plus the ending IDE. So if you wanted to write the anion for fluorine here, that would be fluoride. So it has taken the ending of INE and removed it to give you IDE. If you want to look at another one, so let's take a look at chlorine, for example. Let's look at oxygen instead. First, we want to try and figure out, okay, what's the charge of this guy? So if you were to take its group number, which is 6, subtract that from 8, giving you -2, you could write the symbol of your cation as oxygen 2-. Now, if you wanted to write the name, again, that's the first syllable plus the ending IDE. So if the name is oxygen, your first syllable is ox, so you would drop that down and add IDE. So together you are forming those different cations and anions. The only difference is if you had something like this, where you have your monoatomic ions for different groups. Different groups, we're looking down here at our transition metals, okay? And in your transition metals, you have different cations that you can form. And the cool thing about the transition metal is your cations can have different charges. So to figure out the charge of any of those transition metals, you're going to use either Roman numerals or the charges of some, it'll be given to you in that name. So for your Roman numeral idea, if you have Fe2+, again, that is given to you, telling you it lost 2 electrons, your name would then be iron, because that's its element name. And your Roman numeral would be 2 to denote that charge. So your charge becomes the Roman numeral. Again, there's no spaces between the element and this Roman numeral, and the number in that parentheses can change, and that's the unique part of being a transition metal. So for example, if you had iron 3, you would write the element name, which is iron, and then include in the parentheses 3. A few of them only have 1 charge, so it's sometimes difficult to remember because they don't give you a Roman numeral. So make sure that you know these exceptions, because it won't make sense whenever you're looking at it on a test, since it won't have your Roman numerals. The first one is silver, which is always +1, as well as cadmium and zinc, all having +1s, and or cadmium and zinc having a +2 for each one of those. Sorry about that. So anytime you see those, you may not see a Roman numeral. It just depends on who has written it at that point, but usually they do not have that Roman numeral. So let's give this a shot. So we want to try and name these ions by the things that we just figured out. So we have potassium. So first of all, we're going to need to look at a periodic table to see where that lies, to determine how many, not only the symbol, but how many electrons are gained or potentially lost. Okay, so we see that your potassium is right here in row 4, group 1. So since it's in group 1, we know that it must have a +1 charge. So let's go ahead and flip back to our PowerPoint. So in our PowerPoint here, we have potassium for our first one. So our syllable or our symbol is a capital K. And since it's in group 1, we know that it must have the +1 charge. So let's look at the second one. Okay, so we're back to our periodic table and we're looking for lead. So lead is Pb. It's down here. You can see that's number 82. So now that we know that it is Pb, let's check back with our PowerPoint. Okay, so now that we have our symbol for lead is Pb, it has lost 4 electrons. If you lose electrons, that causes you to become positive. So it must be Pb4+. Since it lost those 4 electrons, it's going to give you that same charge of however many it lost. Now let's finally look at sulfur. Sulfur is going to be on our periodic table, so let's take a look. Sulfur is in group 6A, so if you subtract 6 minus our 8, we'll get our charge, and we also get our symbol here from our periodic table. Okay, so we get our symbol of S, and like I said, it's in group 6, and you subtract 6 from 8 to get your charge of our -2. And that's drawn out here as well in your different PowerPoint slide that you have access to. And you are able to access these at any time as always. And one thing that I do want to point out is something called a polyatomic ion. Now, polyatomic ions are a little bit different because they're going to have more than one atom associated with it. However, they're very similar because they all do have charges, and they're going to make ionic bonds. Unlike those monatomic ions, like I said, it's more than one, and they have a unit that carries that charge. So something that is kind of interesting is how they look. So anytime you see more than one atom grouped together with a charge, you know it's going to be a polyatomic ion. And here's a list of different polyatomic ions. I'm sorry, I don't know why this background stuff is on here. However, I'm going to give you these different ions for any test that you would take, so you don't have to worry about that.